Hey, math friends. So our learning target today is I can explore and use a variety of rates that describe common real life situations. So we talk about rates all the time in real life when we're talking about miles per gallon or dollars per pound, the rate at which something is um, moving, really. So rate is when you're comparing, I kind of forgot a word here, is when you're comparing two quantities with different units. So 60 miles in 2 minutes is the rate. Rate is also known as speed, and it's also known as this thing called slope. That's the same as 30 miles per minute. So the rate is 60 miles in 2 minutes. Then more specifically, this word called unit rate, the amount of miles traveled in 1 minute or in 1 unit is known as the unit rate. They're equal, they're both speeds, they're growing at the same rate, but there's just something special about this thing called the unit rate because it's a comparison out of one of the units. So, likewise, $24 in 2 gallons is the rate, is the same as $12 in 1 gallon, is called the unit rate. So how much for 1 gallon of gas? Likewise, $9 for 2 coffees at Starbucks is the same, that's the rate, is the same as $4.50 for 1 coffee, which we would call the unit rate. So how much for 1 unit of coffee? So it just gives you kind of a relationship there. They are everything on this page is equal in comparison. They're growing at the same rate. They just have some different vocabulary. So let's try some. The speed is equal to the rate. Just so you know, speed equals rate. A subway car travels 2.5 miles in 5 minutes. Find the speed of the car. So 2.5 miles in 5 minutes, which means that if we were to calculate that down to the unit of something, we simply just need to divide. So 2.5 divide by 5 means that it is traveling at a half mile per minute. That's the unit rate because that reduces to 1/2. So a half mile per minute is the speed. Now they're equal to each other. 2.5 miles in 5 minutes is the same as 1/2 mile in a 1/2 mile per minute. They're all speeds, but this is a special thing called the unit rate. So if we know that it travels a half mile, 1/2 mile in a minute, how far does it travel in 11 minutes? So you can use some mental math there. You could do some finger counting there. There's lots of options of how to tackle that problem. But essentially, looking for a pattern that we are multiplying by 11 minutes here. So then we would need to multiply by 11 miles. That idea of whatever you do to one side, you have to do to the other side to keep it balanced. That would be the same idea there of how far are we traveling then in 11 minutes. So we would say that we are traveling 5.5 miles in 11 minutes. So there's lots of ways to get to that. We could estimate, we could problem solve, we could do anything by hand there. So let's continue to talk about speed or rate. So if Nate can swim 200 yards in 2.5 minutes, that's his rate. That's also his speed. So I'm asking what is his speed? I'm really asking what is his unit rate. So break it down to 1. So to do that, you simply just need to solve this problem on the left, which says divide. 200 divided by 2.5. So we have 200 divided by 2.5 is 80. 80 yards per minute is his speed. Now, as we've stated, these are equal to each other. But this just breaks it down into more of a unit rate or a slope. They are equal, they're growing at the same rate, but there's something very special about this thing called the unit rate. Next problem, let's give it a shot. So you bike 30 blocks in 20 minutes. So they must be pretty long blocks, but 30 blocks in 20 minutes. That's your rate. What's your speed? So really this operation just means division. So 30 divide by 20, divide, you're just dividing, is 1.5 blocks per minute. That's your speed. That is what we call the unit rate. Sweet. So not hard math here at all. It's just a division problem. You're just dividing to get the speed. Next problem. The International Space Station travels 57.6 miles in 12 seconds while orbiting the Earth. What's its speed? So we don't know. How fast is it traveling per second? They will be equal to each other. This is the rate that we were given. So how do we break it down to the unit rate and get the speed? They're both speeds. One's just a more specific unit rate speed. Division is the operation here. Just simply divide. 57.6 divide by 12 gives us 4.8 miles per second is the speed or the unit rate. So speed, unit rate, same language. Now let's talk about money. How is money related to the idea of speed and unit rate? They're all kind of functioning the same way, breaking it down per one. So this is a 12 ounce, this might be hard for you to see, but that's a 12-ounce can of grape juice. And I say, what's the rate? What's the cost? Kind of, what's the speed? What's that same idea? So we're saying that it's $1.19. Money, by the way, always has to go on top. Money is always going to go on top because it's dependent on factors like how much are you going to buy, how fast are you going, blah, blah, blah. For 12 fluid ounces of grape juice. So we want to know how much does it cost for 1 fluid ounce of grape juice. That's the rate. That's the unit rate. So we know that division is the operation. We're going to divide down. So $1.19 divided by 12. I'm going to round. Got to round. Type it in, type it in, type it in. Because of the decimal, the way it came out there, I'm going to round it that it's about 10 cents for 1 ounce. So we call that per. 10 cents per ounce. Simply just a division problem. Just a division problem. All right, let's try this one over here. So a case of pop costs $6.49. So $6.49 for a case of pop. A case, maybe that's language you don't know. A case of pop is one of those rectangular prisms that you could kind of carry around. It has 24 cans in it. If you didn't know that, it doesn't matter. So a case of pop has 24 cans in it. So we want to know how much is it per can. What's what we call the unit rate. We know that the operation, because this is a division sign, we simply are just going to divide down. So we have $6.49 divide by 24. Gives us that it's about 27 cents per can to buy that case of pop, which is interesting because if you buy it at a concession stand, they charge you $1, right? You buy it at a gas station, they maybe charge you $2 or a vending machine. So you can see that there's definitely money to be made on selling cans somewhere other than when buying it in the grocery store. So that's an interesting question, but those are our rates, our price. So this problem, $4.80 for 6 cans. That's the rate. That's the rate. So what's the unit rate? What's the price per can? How much for 1 can? The operation is division. We're simply just dividing down. So some of you could probably do this one in your head, but I'll give you a chance to type it in. Again, pause the video if I'm going too fast. We would say that the unit rate then is 80 cents per can. 80 cents per can. That's the rate. All right, we're almost at 10 minutes. So let's take a look at what we have left here. I might cut that one. Let's talk about the rate here. What does the 0.4 to 122 represent? This is a kind of a different twist on it. 4 tickets. So the point we're talking about is this point right here on the graph. The data point of 422. 4 tickets costs, kind of like multiplication table works, where you follow down and over, $120. So 4 tickets, $122. So what's the unit rate? Well, it's $122. Money has to always go on top for 4 tickets. So what does that mean? That's the rate. So what does it cost for 1 ticket? Well, that's just a division problem. We divide down. So we would say that that's $122 divide by 4 tickets. We're just dividing here. Means it costs $30.50. Now you might, your calculator you might need to fill that placeholder in there. That's the unit rate. Now they're equal to each other. It is true that $122 for 4 tickets is the same as $30.50 for 1 ticket. That's true. So if it's $30.50 for 1 ticket, that's the rate. In part C, we're asking, what does it cost to buy 10 tickets? Some of us can mental math that because we're just multiplying by 10. Having a hard time with my pen here. So one option is just to recognize that we're multiplying by 10 top and bottom. Just looking for a pattern. We multiply by 10, we just move the decimal. Or some of you might have another strategy that you're using of how to estimate that. You might be even finger counting it. You might be typing it in your calculator. But the question is, what does it cost to buy 10 tickets? Well, it's $30.50 for 1 ticket, and so therefore it's $305 for 10 tickets. So that's our answer to part C. All right, we're at 12 minutes, so I think I'm going to skip this problem perhaps. Actually, yeah, we're going to do just these last 2 on the page here. All right, so rate, unit rate. So we have $2.35. Money has to go on top. For what? For 12 eggs. What is the unit rate? So we know that this is a division problem. We simply just divide down. So $2.35 divided by 12 eggs is how much is it for 1 egg? So it would be about 20 cents. About 20 cents per egg. Division problem. And the last problem of the day. There's the price for 5 gallons of paint. $74.75 for 5 gallons of paint. That's the rate. What is the cost per, that language we're using here is per gallon. We know that this is a division problem. Division problem, just divide. So $74.75 divided by 5 means that the price per gallon is $14.95 per gallon. So the lesson today is about rates. So let's say we have that something is $12 for 6 gallons. That's the rate. That would be about $2 a gallon, right? So that's $2 for 1 gallon, right? So rate and speed are all the same thing. They're equal to each other. That also means that it could be the cost. We're really talking about this idea of per one, meaning unit, per unit. Okay, so that's the lesson for today. That kind of hits our learning target on something called rates and unit rates in real life situations. All right, have a glorious night.